Hey, how's it going, everyone? So for this video, I'm going to show you how to replace a pinion seal. The vehicle that we're working on is a 2002 Dodge Viper. It's a Dana 44 diff. It is an independent Dana 44. We've got our axle shaft there and there, which makes it unique, but the pinion seal portion of it's the same as if it was a Jeep or a pickup truck or anything like that. So our leak, we have this collar and it directs the fluid down. So we got a little bit of fluid leak there. I've already gone through and removed the drive shaft from the vehicle. So we have our teeny tiny drive shaft for this this Viper. It's got a T56 rear trans and the engine's pretty far set back, so it doesn't really need that much of a drive shaft lengthwise. So our next step is going to be to mark the pinion nut to the pinion gear itself. The reason why we do this is so that we can get the yoke and everything torqued back up to round about the same preload. It's a good idea to try to feel the turning torque of this while you can. Now obviously, because we're doing a pinion seal, we're not going to be taking off the brakes and the wheels and everything to measure this properly. So I found usually it's best to use a auto punch and to make a mark on both ends. So we'll use the auto punch and mark a little area. You don't want to use a pen because you're going to probably go through and clean this with brake clean, and that would be counterproductive because you'd lose your mark. But just using an auto punch and making two little tiny divots. Can't really see them on camera because of the glare, but I've made two marks right here. So we should be all right in the sense of getting the nut back in the right location. So the next step I'll do is I'll buzz this off and then we'll pull the yoke out. All right, so there's a couple different methods on how to get the seal actually removed from the housing. So this is our new seal. So normally if it has a lip that sits flush with the housing, you can use some sort of puller or pusher to pry these out. This is sitting inside of the housing, so we actually have to pull it out. So conventionally you'd use a hook puller tool like this. Now these go in between the seal and then pull up, and you can pop the seal out. The downside of these is these hooks can be very, very sharp and gouge the housing. Our particular diff has an aluminum housing, and we don't want to do that. It can gouge very easily, especially to this tool rated steel. And if we cause a gouge in it, then there's fluid can get around the seal and cause a leak. So what I'm going to use is I'm going to use a slide hammer with a screw on the end, screw adapter end. So I'm going to screw this self-tapping screw in, and then screw that adapter to the slide hammer, and then slide hammer the seal out. You're less likely to damage anything that way, and it comes out a lot cleaner. All right, so with our old seal out, it did come out in two pieces. This inner ring came out, and then the ring that actually is attached to the housing needed to have a little bit bigger hole drill than the larger screw used, but it popped right out. Interestingly enough, our new seal is actually one piece, so must be an update from having that issue. So one of the things you want to do is, because this is an updated seal, we want to make sure that it's the right size. So we're going to compare the two and make sure that they have the same lip and everything. They look pretty good, so I'm confident that this seal will work. Our next step is we're going to have to use a installation tool. So this is just an aluminum kind of cup that has to fit onto the seal just right. We don't want to hit on the actual lip portion of the seal, that will damage it. So this tool's sitting right on that groove right there, which will be enough to support getting the seal in. So you just tap this in, we're going to hit it flush with the housing, and then we can install our pinion yoke. Alright, so at this point we're ready to install the yoke. I went through and cleaned up the small lip that the lip seal can create. Just a little bit of Scotch-Brite will clean that up. So we'll slide this on and then torque it to spec. I also like to use a little bit of Teflon on the threads, just very, very light amount to prevent fluid coming out through the splines of the pinion. put the washer on and then our nut, and we'll line it up with the points that we made so we can get it back in the right preload. Now you're probably looking and seeing that this is a chrome socket, and I'm going to be using an impact gun with it, and you'd be correct that that's not the proper way to do it. Unfortunately, Dana Spicer, who makes this rear diff, machined this yoke to where you can't get an impact socket on it, so you have to use a chrome one. So wear eye protection. So double checking our marks line up, and I can turn this, and this feels like the same preload that we had when we started. So marking it gets you in the right ballpark. If the vehicle has really high mileage, you probably do got to crush the crush washer just slightly more, but be prepared for the diff possibly making noise afterwards. So you really want to beware when you do pinion seals on older vehicles that you may be causing a diff issue, and it may be time to just overhaul the diff completely. So our next step is going to be to reinstall the drive shaft, and part of that is going to be adding red Loctite to the drive shaft bolts. These are just little 5/16 guys. They need a little bit of help to stay put. So only other things to note before I put this on, because I skipped it at the beginning, this masking tape is there to prevent the two bearing caps from coming off of our yoke right here. You put tape around it to prevent them from falling out and the needle bearings going everywhere. So at this point the drive shaft's installed, I can cut the tape back and then get the drive shaft reinstalled on the vehicle fully. So at this point stuff started to go a little south. I had not done my due diligence to double check to make sure that all the hardware was good while setting everything up. I noticed when I tried to thread in one of the retaining strap bolts for the drive shaft that it was cross-threaded and it wouldn't go anywhere. After removing it, I came to find out that all the threads were missing on the end of it. Now this is done by a prior repair and does require it to be replaced. There's a lot of reasons why I can't tap the new threads on that. It's not really a safe thing to do, especially on a drive shaft where that can come loose and the drive shaft can come apart. So at this point I had to wait quite a long time for a new yoke to arrive so that I could fix the issue. Golden threads are stripped. All right, so stuff went south real quick. It was a bit of a debacle. So this is the original drive yoke for the diff. I don't know how well you can really see it, but the threads are all stripped out. I didn't notice that when I was tearing it down. So the threads are stripped out for both of these strap retainers, which means that there's a high likelihood that this drive shaft could fall out, especially if there's one. Now you would think that you could go through and tap the holes, but these have special threads. They're a 9 by I think 175 weird threads. You can get a tap for it, but it's really not advisable to tap something like this that you know, you need to have good solid threads to. On top of that, there's not much meat to get into. So the issue with this one was the car's 2002, and that's way out of the year range for the manufacturer to keep making parts. So manufacturers are legally obligated to make parts for vehicles 11 years after production. So we're way past that on this vehicle. So it was really difficult to find one of these. What we did have to do is, after 3 weeks, we were able to find one to a newer car. It is a bit different. There's a bit of construction different in how, you know, it's shaped versus the old one. But what it looks like is, it looks like the spline's the same size, the U-joint's the same size, the drive shaft will fit in correctly, and the straps will go on as well. But in typical fashion, one thing didn't have to work, and the nut had to be ground down slightly so that it would fit inside of this and it would get torqued down to spec. So it's been a bit of a pain in the ass to get everything to work, but in the end, I guess we'll get it together. So now we'll go back to where we were and start redoing all of the tightening procedure. New drive yoke is in with the new seal. Everything's all cleaned up. The drive shaft bolts are torqued. Installed new strap bolts due to the ones being stripped out. So at this point, it's time to test drive the vehicle. Thank you for taking the time to watch the video, and I'll see you in the next one.